The EarthChem Library, as I mentioned already before, is a data repository that publishes and archives user-contributed data. They can be geochemical, petrological, geochronological. We will always take a look at the data. We do actively curate these data, do a review of the data, and would tell you if the data are not appropriate for our system. But our goal really is to help researchers make their data fair, make the data findable for others and accessible, but also make sure that these data can be integrated into larger collections of data, so become interoperable, and that we make them reusable by making sure that the data have all the information necessary about the provenance of the data, data manipulation, and so on. So we do follow international best practices for data repositories. We provide guidelines and help for users to document their data, the provenance and quality. Our curators, such as Lucy, who just spoke, they review these submissions. When a submission is approved and having all the necessary metadata, we register them with the DOI so the data becomes citable, and many publishers will ask you to include the DOI of your data set in the publication. So you will see that when you are trying to submit manuscripts increasingly. We also make sure that the data are archived for long-term access, and we do that in Amazon Glacier right now. And an interesting, really powerful aspect of the way we handle the data is that we're linking the data to the publications, we're linking them to the samples, to funding awards, to orchids of the authors, and so on. So it builds a network of information that can be used in many different ways. And again, we are trying to increase machine-readable interfaces where metadata about the data sets can be discovered by other data portals or by commercial search engines. EarthChem, as I mentioned, it's following international best practices, and as such, it is recommended by publishers, showing here Nature as one of two repositories that Nature recommends for biogeochemistry and geochemical data. We accept a wide range of data types, mainly sample-based data, but we do have time series measurements and so on. Most of the data we have are chemical physical properties of different materials, experimental data, be they kinetic, thermodynamic experiments, and so on. And we do have sample descriptions as well. So it's pretty broad. And it is new data that are published in the literature, but then also data sets that are compiled in part from databases like the EarthChem synthesis or GeoRock and so on, where people have written papers about these big compilations about syntheses. I mean, the work that Brennan has done has data sets that also should be recorded so that the results are reproducible. We have published a few method descriptions, and we're trying to figure out how to also include models and software. This is part of the new project that Lucy mentioned already, where we're working with Enki to build a closer integration of models and data. So we have a range of services for you that make it easier to submit data to us. We have an online submission form that you can use to put in the bibliographic metadata for your data set. You can use templates that we make available to put together all the right information about data provenance, about uncertainties, and so on. You can access your submissions, or even you can save when you don't manage to finish a submission, you can save it. That is all accessible via your own dashboard in the system. And we deliver twice a year a report on how many downloads, how many times your data set has been downloaded. And clearly, we're always there with user support to answer any questions and help if there are any problems. We are in the process of making some substantial changes to our data submission process. And a really important one is that we are implementing data communities. This is if you have a special community, such as, you know, everybody working with tephra data. We had requests from a community that was doing clumped isotope measurements. They suggested best practices, how to document clumped isotope measurements and so on. We are creating these as communities with a web page where you can post templates or post a description of best practices and so on, and also have a customized data submission form, and potentially the communities can be searched individually through the ECL search. We're closely integrating with the Astromaterial Repository because the EarthChem Library has already received a number of data sets for lunar samples and for meteorites. Okay, this is just a brief screenshot of the data submission form where you can go and you can see when you log in, your name is already recorded. You can link the funding sources, provide a data set title, and so on. I don't need to go deeper into that. We have a lot of help resources, online tutorials, YouTube videos to show you how to go through the process. These best practices, as I mentioned before, are based on an effort where publishers and data facilities in the geochemistry got together in sort of 2008, 2009, and agreed on recommendations for best practices. They were called the Editors Roundtable. And this is what we have implemented as best practices for the EarthChem Library. We only accept tabular data. If there are tabular data, they have to be in CSV or in Excel format or text format, but no PDFs or documents or PNGs or whatever. There needs to be a rich set of metadata, at a minimum sample location, sample type. The technique that was used, was it done by mass spectrometry, was it done by XRF, and so on, and in which lab were the data created? Obviously, units, uncertainty if possible, standard measurements, and so on. If it is a compilation, we are asking for a full list of all the data sources so that people can get credit for the data they have contributed to these databases. And clearly avoiding abbreviations is critical for the long-term use. If nobody knows what ABC in your column heading means, then that makes a data set pretty unusable. This is just a landing page for one of the data sets that we received. One thing I wanted to point to here is this is a data set that is not yet available. So when you submit your data, you can set a release date up to 2 years, up to 2 years into the future. Link to the funding source that takes you directly to the funding agency's landing page of the award, if that exists. And we also encourage the use of the IGSN, and if a data set has or refers to samples by IGSN, we include them in the metadata record can all datasets have data for a specific sample. And the IGSN then links to the landing page at CISA, at the System for Earth Sample Registration, that shows you the information about the sample. It also shows, if provided by the user who registered that sample, it shows where this sample is curated. In this case here, the sample is at the Marine Geological Samples Laboratory at the University of Rhode Island. So you can contact that repository, sample repository, if you're interested in further working on that sample. So just at the end, some additional advice when you manage your data. The submission is something that happens at fairly late in the life of data. It is good to think about how you will manage your data, how you will share that data at the very beginning of a project. And funding agencies in many countries are already requesting data management plans. So when you start a project, think, what data you will acquire, how much it will be, clarify with your collaborators who is responsible for which data and what licenses fit everybody's constraints in some way. Identify the data repository and check what you are supposed to provide in the end, so that you can start gathering any relevant metadata while you're acquiring the data, and not, you have to find that metadata years after you acquired the data, which is sometimes quite challenging. And register your samples early when you have collected them, so you have the IGSN and you can keep it on your sample label and on your sample vials in the lab, and you can always track that sample through its life.